This video will provide an overview of the different physical and chemical properties that we can observe in matter. So before we get into this, let's go over a review of the key points. Remember that matter is the stuff of the universe. The other thing out there in the universe is energy. Matter is defined as anything that has mass and volume. It has some amount of stuff in it that can be weighed, and it takes up a certain amount of space. We can classify matter as an element, a compound, or as a pure substance or a mixture. And matter has both physical and chemical properties, and that's going to be the focus of this video. Physical properties can be observed or measured without changing the substance. So you don't have to do anything to it. You look at it, you touch it, you can determine physical properties. Whereas chemical properties can only be observed during or right after a chemical reaction, so they require a change in the substance. Starting with physical properties, they also can be intensive or extensive. Intensive starts with the word in, so if you think inside, intensive properties are inside the matter. They are not affected by how much you have of that matter. So color is an example of an intensive property. Doesn't matter how much gold you have, it's always going to have the same color. Whereas extensive properties are affected by the amount of matter that you have. And so something like the mass of a sample will change depending upon how much you have, or the volume the same way. So extensive properties are something that can change. So let's look at some examples of physical properties. Density is a measure of how tightly packed the substance is, the molecules that are in that substance, and we calculate that. We can put a number at it by dividing the mass of your sample by its volume. So with our two examples down here on the left, we have a much more dense substance. You can see it has more molecules in it than the substance, the sample on the right. Hardness is another physical property, and it's a measure of how easily something can be scratched. So in earth science, we use the Mohs hardness scale to identify minerals, as you see down here, that this substance is being scratched by another mineral, and there's a whole chart you can look up to see what might that mineral be. These next three properties are very common in metals. They have luster, which means they are shiny. They are ductile, so they have ductility. We can stretch them into a wire. And they have malleability. You can actually pound them into a thin sheet, like this copper foil that we have an illustration of, or aluminum foil that's probably in your kitchen. Then brittleness is another physical property that talks about how easily something breaks upon impact. So a clay pot is very brittle. Viscosity is talking about how easily, or really how uneasily, how not easily, a substance pours or flows. So a substance that is very viscous, like honey, does not flow very easily, whereas water does. Electrical conductivity is another physical property, and it says so right in the name. It's a measure of how easily a substance conducts electricity. Solubility is a measure how easily a substance would dissolve in water or another solvent. And then we have the various melting or freezing or boiling or condensing points that change the temperatures at which a substance changes state. And whether it's melting or freezing depends upon which way you're going, because if you're going from a solid to a liquid, it's melting, but if you're going from a liquid to a solid, it's freezing. Other physical properties include magnetism, or how transparent a substance is, what its specific heat is, that's how much heat energy it absorbs before it changes temperature, perhaps its texture or its odor. These are all examples of physical properties. Now, chemical properties cannot be determined by looking at or touching a substance. You need a chemical reaction in order to determine the chemical properties of a substance. And you're determining the chemical properties of what you're starting with, not what you're ending with, because in a chemical reaction, you can see that atoms get rearranged and new things are made. Examples of chemical properties include combustibility, which is the ability of a substance to react with oxygen and produce heat and light, as we see happening over here with this candle. Or corrosion, another property that's specific to oxygen. It's the ability of a substance that gets broken down by reacting with oxygen. We usually call this rusting. We have an example of corrosion with iron on this steel pipe. And so these are both examples with oxygen, but in general, reactability, the ability of a substance to react or maybe to not react with another particular substance, is a chemical property. So there's many types of reactability because it depends on what substances you're talking about. This example here in the picture is an example of starch reacting with iodine. So in this situation, the iodine, the brown substance, is being turned into sort of a blue-black color because it is reacting with starch. So its chemical property is that it can react with starch. Toxicity is another chemical property, and this is the ability to damage living organisms. Whether something is acid or base, acidity or basicity, specifically is how that particular substance can donate or accept hydrogen ions, and we measure that with the pH scale. So not all substances will register as acidic or alkaline. Alkaline is another word for base. We've got two words over here for the same side of the pH scale. But that is a measure of a chemical property. And then things involved in radioactivity or half-life, which is related to radioactivity, the ability for nuclear fission or nuclear fusion to occur. Here we have some fission, we have it breaking apart. That also is a chemical property. The elements on the periodic table in the same column share similar physical and chemical properties. So we sometimes call these columns families or groups. But the strength of that property will vary as you move down a column. So for example, from this first column, which is our alkali metals, if we look at they all react with water. So we have a comparison here of lithium, that it'll bubble in the water. Sodium, you'll get a little bit of a flame if you put the metal in a container of water. And potassium, so we've gone from lithium to sodium to potassium. We're moving down the group. Potassium does quite an explosion. You can see it's kind of like fireworks. There's sparks coming off here. And so as we move down this group, the intensity of the property gets greater. On a final note, I want to say that the properties of the compound are not the same as the properties of the elements in the compound. And so we make water from hydrogen and oxygen. Hydrogen by itself as an element is a gas at room temperature and highly explosive. Remember the Hindenburg. Oxygen is a gas at room temperature, and it increases the rate of combustion. And then water, what we get is a compound that happens when hydrogen and oxygen are put together, is liquid at room temperature, and you can use it to put out fires. And so what you make as a compound is going to have a very different property than what those original elements had. These properties of the substance can be used then to identify the substance. You can do some forensic to figure out what exactly it is. And also the properties, because they change when a compound is made, they will show that a chemical reaction has occurred. So that's the overview of physical and chemical properties of matter.